All right, welcome everyone to today's explainer. So today we're doing something really exciting. We're bridging the gap between your custom applications and state-of-the-art models like GPT-4o and o1. Look, if you've been playing around with web interfaces to interact with AI and you're ready to take that massive leap into real programmatic integration, well, you are exactly where you need to be. Let's dive right into the architectural blueprint for doing this securely and efficiently. But first, I really want you to think about this. What actually happens when an API key leaks in client-side code? Honestly, the short answer is absolutely nothing good. Without strict authentication and defensive management in place, an exposed key can literally lead to runaway billing from infinite loops, unauthorized usage, and just catastrophic financial risks. I mean, accidental bankruptcy is definitely not a feature you want to ship, right? Securing these credentials, it's completely non-negotiable. Okay, let's dive into this. Here's the secure architect's blueprint we're going to follow today. 1. The OpenAI API bridge. 2. API key security hygiene. 3. Tokenomics and cost computation. 4. SDK integration. And finally, 5. Mastering error handling. All right, let's kick things off with Section 1, the OpenAI API bridge, and how we connect custom apps. So here's the thing you have to wrap your head around right away. The OpenAI API is not ChatGPT. ChatGPT is a polished, finished web interface. It automatically handles the memory, the conversation state, the rate limits, the whole shebang. The API, on the other hand, is just a programmatic bridge. When you build with it, you are the one responsible for strict HTTP bearer authentication. You have to manage the state of the conversation, and you have to track your own tokens. It really demands a highly structured defensive architecture from the ground up. Let's move to and see how this builds into Section 2, API key security hygiene. These are the absolute non-negotiables. Okay, listen closely because this is absolutely crucial. Running API calls directly from client-side execution, we're talking browser, JavaScript, or a mobile app here, is a fatal flaw. Doing this completely exposes your secret bearer tokens, which usually start with skproj, to basic reverse engineering or even just simple network inspection. There's just no way around it. You must always rely on server-side execution. You've got to route your API requests strictly through the armored vault of a backend server or serverless proxy, period. So how exactly do we establish that secure vault locally? Well, there's a methodical 4-step process for your environment configuration. Step 1, create a secure working environment. Step 2, generate a restricted API key right inside the OpenAI platform. Step 3, and this is vital, save that key strictly inside a local.n file. Literally never hard code it into your main scripts. And step 4, immediately add that .n file to your .getignore file to prevent it from ever being pushed to the public web. Now, taking those steps into a production environment requires some strict zero hard coding paradigms. First, obviously, never commit .n files to Git repositories. When you do deploy, you need to store those keys in dedicated cloud secret stores. Think AWS Secrets Manager or GCP Secret Manager. If you're working in automated environments like Kubernetes or Azure, use short-lived workload identity federation instead of long-lived keys. And finally, you absolutely have to configure hard and soft spending limits in your OpenAI dashboard. That way, if the worst does happen and a leak occurs, your financial loss is strictly capped. No surprise astronomical bills. All right, moving right along to Section 3, tokenomics and cost computation. Before we can even think about calculating costs, we really need to define the core currency of this whole LLM economy. A token. So what is it? A token is simply a chunk of text that the models read and write. To put that into perspective, one token is roughly equal to 4 characters, or about 3/4 of a standard English word. Whenever you send data up to the API, and whenever it sends data back down to you, every single piece of that text is being chopped up into these tiny tokens. And this brilliantly illustrates how your cost ledger is effectively split right down the middle. On one side, you've got input tokens. This is the actual prompt payload you're sending over to the model. On the flip side, you have output tokens, which is the generated completion the model writes back to you. The reason the split matters is that different models, like GPT-4o versus, say, GPT-4o mini, actually charge completely different rates for input versus output. So really understanding this dynamic is absolutely crucial for keeping your budget in check. Next up, Section 4. Let's get into the actual construction manual, SDK integration and execution. Now, while you technically could manually write out raw HTTP requests using curl, you really shouldn't. The official Python and Node.js SDKs provided by OpenAI perfectly wrap all those complex HTTP protocols for you. They automatically handle the request serialization, they manage that HTTP bearer authentication header securely, and they parse errors cleanly. Using the official SDK isn't just easier, it is fundamentally the most resilient way to handle your payloads. So what does a truly secure Python pipeline actually look like in practice? Well, it follows this exact flow. First off, you securely call load_.env to pull variables in from your environment. Second, you explicitly check that the OpenAI _API key was successfully grabbed using os.getInv. Third, you initialize your client by passing that variable in. Notice what we did there? We kept the key completely out of the hard-coded logic. It's safe. And finally, when you get that response back from the model, you can extract the metadata using response.usage.total tokens, so you can keep a close eye on those costs we were just talking about.
Which brings us to our final component, Section 5, Mastering Error Handling.
Here's the reality. Networks fail and rate limits exist. OpenAI enforces strict request per minute and tokens per minute limits, which vary based on your specific account tier. Every time you make a request, the API actually sends back HTTP headers packed with vital rate limiting data. X rate limit remaining requests tells you exactly how many calls you have left in the bank. X rate limit reset tokens tells you exactly how long until your token limit resets. And maybe most importantly, if you do hit a wall, the retry after header tells you the absolute minimum amount of seconds you have to sit and wait before trying again. Because if you ignore those headers, or you just blast requests too quickly, or maybe your credit balance just zeroes out, you are going to slam straight into this number, 429. That is the dreaded HTTP 429 too many requests error code. And let me tell you, when you hit this, your application is going to crash hard unless you've built in some solid exponential backoff strategies. To prevent those crashes and ensure your app degrades gracefully, you've got to actively catch specific exceptions. Fortunately, the official SDK maps these out beautifully for us. You need to catch an authentication error if somehow an invalid API key gets passed. You absolutely must catch a rate limit error for that 429 code we just looked at. That's what should trigger your backoff logic. You'll want to catch an API connection error for basic network timeouts when the internet just decides to blink. And finally, just a general API error to handle any unexpected system issues happening on OpenAI's end. So the crucial point here is this. The official OpenAI SDK is already doing a massive amount of the heavy lifting for you out of the box. By default, it actually automatically retries eligible rate limit and connection errors 2 times. It inherently honors that retry after header we talked about, and it automatically applies a short exponential backoff. So you don't even have to write a complex retry loop from scratch. You just need to know how to configure it and correctly catch the limits when they are eventually completely exhausted. Wow, okay. We've covered the architecture, the security hygiene, the tokenomics, and the resilience patterns you need to really master the OpenAI API. But I want to leave you with this final provocative thought. Go look at your current projects today. If your code repository was accidentally made public tomorrow morning, would your OpenAI keys be safe? If your answer is anything other than a 100% confident yes, then it is time to go right back to step 1. Audit those .env files and lock down your zero hard coding security paradigms. Thank you so much for joining me on this explainer. Now go build something incredible and keep it secure.